Okay, now let's move to the third activity, orchestrating the cloud with Kubernetes. In this lab, you will learn how to provision a complete Kubernetes cluster using Google Kubernetes Engine and deploy it and manage Docker containers using kubectl. So let's click on it and let's jump right to this. As always, before starting the lab, let's just go through all the activities. This is the title, Orchestrating the Kubernetes Cloud with Kubernetes. Our first task is always doing the setup. We're already familiar with this, getting the username, the password from the panel when we open it. Then we will activate Cloud Shell. These steps are optional to see the active account name, the project account. And here we will set the compute zone. And we will create to start the cluster with this command. So it says task 1, get the sample code. We will get this code, running these commands and moving into a directory where once we list, if we want to check what's inside of that directory, we will type ls and we'll see there will be all of this, which is the code to be used. Now, task number 2 is about a quick Kubernetes demo. So to get started, we will run this command and we will create an instance of nginx container. Now, after that, it says to get this command, the kubectl get pods, to see what's running on that container. Once the container is running, we can expose it outside using this command, kubectl expose. So behind the scenes, Kubernetes created an external load balancer with a public IP address attached to it. Any client who hits that public IP address will be routed to the pods behind the service. Okay, and we will be able to open that in our web browser. That is for task number 2. For task number 3, we will be talking about pods, which are the core of Kubernetes, like the minimum unit. So pod represents a a collection of one or more containers. Generally, if you have multiple containers with a hard dependency on each other, you package the containers inside a single pod. So this is a logical application or a logical structure. It's not a physical thing, where you can have one or more containers and volumes, shared namespaces, and one IP per pod. You can see it here. Well, actually, task 3 is also to talk about pods, to get familiar with this. And we will dive deeper next. On task 4, we will be creating this pod. So just move into a directory, running this command. We got this file. And we'll start, as I said, most of the commands we will be using will be running kubectl create, and here we have. Now we will examine the pod using kubectl get pods that will be created. This is just to get familiar with what we'll be doing while running all that code. Once created, we will be interacting with those pods. In the terminal, in one terminal, we should have this, and on the second terminal we will be running this. Okay, and now those pods will be talking between them. Now the first terminal start talking with your pod using curl. Yeah. Now use curl command to see what happens when you hit a secure endpoint. So one of these will be asking for a password. We will create an environment for tokens. Here you have curl authorization bearer token. Secure. At this point you should get a response back from our application letting us know everything is alright, and you will check the logs. On the third terminal you will use this flag. Basically you will be interacting with those pods. You will be running 3 different terminals, or we will be running 3 different terminals and executing those. Testing, and when everything is okay we will exit. Now for task 6 we've got services. This is a key point. Pods aren't meant to be persistent. They can be stopped or started for many reasons, like fail livenesses or readiness checks, and this leads to a problem. What happens if you want to communicate with a set of pods? When they get restarted, they might have a different IP addresses. That's where services come in. Services provide stable endpoints for pods. And here we can see it. We will use labels to select pods, internal or external IPs. Now, how to create those services is task number 7. Again, we will change to this directory. We will explore the configuration file, which is this. We will create this pod. We will explore it. This should be the output, what's inside of this file. And we will use kubectl create. This should be the output. Now, to add labels, oh, by the way, we will have to use firewall rules. So use gcloud compute firewall rules command to allow traffic to the monolith service on the exposed node port. Yeah, so you can interact or connect. We will enable this firewall rule. Then we'll check the progress. So first get an external IP address from one of the nodes. Now try hitting the secure monolith using curl. There will be a failure. And some questions we will have to answer from this. Why you are unable to get a response, how many endpoints does the monolith service have, and what label must pod have to be picked up by the monolith service. Then on task 8 we will be adding labels to pods. We've checked this command previously, kubectl get pods. And after this, we will be able to connect. Always keeping in mind to change this external IP that will be different from each one of us on the exercise. On task 9, we will deploy the application. And, well, explain what's deploying it means. And for task 10 is where we will be creating the deployment. Again, we open this Helm file. We will create a pod. We will expose it. Check services. And with this command, changing the external IP, we should be able to finish the task. Okay, now that we have a better idea of what we will be doing, So let's start. Yes, I'm not a robot. I will verify my identity. I will use 1 credit of my credits available. I click on Open Google Console. My student, this is my new user account. Remember, always get this from username, copy this, then paste it here and click next. Now our password. Copy and paste. If you do this right, agree with the terms. On the upper right part, you should read student something, not your personal account. And let's see, what do we have here? We already started the lab. We already opened the console, use our username and password. So let's activate Cloud Shell. We know Cloud Shell is activated on this icon on the top right corner. We will continue. This step is optional, but I always like to run it so you can see it. This is to let's authorize Cloud Shell. This is the active account. And you can also check the project ID with this command. The one that ends in 123, which is the same here, ends in 123. Cool. Now, let's move. Google Kubernetes Engine. In the Cloud Shell environment, type the following command to set the zone. We will be setting the zone. We will set it to US Central 1B. This is done. And now let's start the cluster. Creating cluster into US Central 1B. Cluster is being configured. Working on it. So it usually takes around 5 minutes or so. And here's the explanation. Kubernetes Engine is provisioning a few virtual machines behind the scenes for you to play with. Once we will finish with that, we will get the source code from the Cloud Shell running this command. Okay, now this is created. Let's get the source code. We're just copying all these files. The operation is now completed. Let's change to this directory and list the files to see what we're working with. So just type ls, and we got cleanup, deployments, and jigs, pods, services, TLS. The same files. Now let's move to task number 2, a quick Kubernetes demo. The easiest way to get started with Kubernetes is to use kubectl create command. Use it to launch a single instance of the Nginx container. So let's run it. The deployment is created. Okay, for now, all you need to know is that deployments keep the pods up and running even when the nodes they run on fail. Oh, that's cool. So use kubectl get pods command to view the running Nginx container. Let's see if it's running. Yep, here it is. This is the name. So it's ready. It's running since 30 seconds ago. Once this is running, let's expose it outside with kubectl expose command. Let's do that. And the service is expose. Perfect. Sweet. What does that mean? That behind the scenes, Kubernetes created an external load balancer with a public IP address attached to it, and any client who hits that public IP address will be routed to the pods behind the service. In this case, that would be the Nginx spot. List our services now using the kubectl get services command. Let's see what we got in services. And we got it. This. It might take a few seconds before the external IP field is populated for your service. This is normal, just rerun the previous command, this one, every few seconds until the fields populate. If you go here, if you write it again, press enter. At the first time it was pending, and now we got this IP. I think we will need this. Yep, we saw it. Let's add the external IP to this command to hit the Nginx container remotely. So let's copy the command, let's paste it here, and for external IP, let's copy the Whoa. Let's go again. Let's copy the command, copy, and for the external IP, let's write down 34.7.99. I'm getting this number from here. Now we click enter, and here it is. Welcome to Nginx. If you see this page, the web server is successfully installed. Let's check our progress, and the assessment is completed. Perfect. Now on task 3 is to get an idea of what pods are. and we will be creating one of those. Again, we will change to this directory where we will run this command, this file. So this is a configuration file. Let's create the monolith pod using kubectl again. Kubectl create. The monolith is created. Now let's examine the pods. Once the pod is running, use kubectl to describe command to get more information about the monolith pod. Is it running? Yes, according to the status, it is running. So this is all what happened. And for our task number 5, we will be interacting with those pods. It says, by default, pods are allocated on a private IP address and cannot be reached outside of the cluster. Use kubectl port forward command to map a local port to a port inside the monolith pod. From this point on the lab, we'll ask you to work in multiple Cloud Shell tabs to set up the communication between the pods. Any commands that are executed in a second or third command shell will be denoted in the command instruction. So open a second Cloud Shell terminal. Now you have 2 terminals. Let's open a second cloud in here. Open a new tab. This will be the second. So now you have 2 terminals. One to run the kubectl port forward command and the other to issue the curl command. In the second terminal, run this command. Let's get this. So this is the second terminal. It says forwarding. Yep. Now in the first terminal, start talking to your pod using curl. Our first terminal is the one we have it working, and it's this one. It says a message hello. Yes, you got a very friendly hello back from your computer. Now use curl command to see what happens when you hit a secure endpoint. Let's see that. Authorization fail is the answer we get. Oh, trying to log in. Oh, sorry. Okay, trying to log in to get an authorization token back from the monolith. Enter host password for user. The password is the word password. You have to type it here or copy and paste. Well, we have to. I'll just paste it. Login in cause a JWT token to print out. Yep. Logging in cause a JWT token to print out. Let's see. Yep, this is the token. Since Cloud Shell does not handle copy long strings well, create an environment variable for the token. So let's do that. Enter host password for user. Again, we will copy and paste. The password for user is the word password. Paste. Entered. And this is done. Now use this command to copy and then use the token to hit the secure endpoint with curl. Now we see a message of hello. At this point, you should get a response back from our application letting us know everything is right in the world again. So let's see. Perfect. This is to see our logs. Now, on step 11, we will open a third terminal. Let's open a third terminal. So this is one, this is terminal 1, 2, and now we will open a third one. On the third terminal, we will use this to check the logs. Now, if you use curl in the first terminal to interact with the monolith, you can see the logs updated in the third terminal. Let's see, curl in the first terminal. This is the first terminal. And we will check the logs here. Yep. Use kubectl x command to run an interactive shell inside the monolith pod. This can come handy when you want to troubleshoot from within a container. Let's go to the first terminal and use this. For example, once you have a shell into the monolith container, you can test external connectivity using the ping command. Let's see if we can. Yep, it's working. The ping command worked. Be sure to log out when you're done on this interactive shell by typing exit, and we're out again. Now, on task 6, it talks about services. We will be creating a service. Before you can create our services, first create a secure pod that can handle HTTPS traffic. So let's move to this directory again. We will explore this. This is a file, so you can see. Create the secure monolith pod and their configuration data. Now that you have a secure pod, it's time to expose. Let's create this. Okay, now it's created. Now that you have the secure pod, it's time to expose it. So explore the monolith service configuration file again. You can see it. Oh, this is a file. Now you have exposed the node port here because this is how you'll forward external traffic from port 31000 to NGX on port 443. Now let's use kubectl create to create a monolith service. Let's create it and check our progress. It's not updated, so let's see. Yeah, it says it's created. It should be. Let's see if it's just a matter. Yep, it just took some time to update. Now, use gcloud compute firewall rules command to allow traffic to the monolith service. Yep. Basically just creating the firewall. And it's done. Let's check again our progress, and this task is completed. Now that everything is set up, you should be able to hit the secure monolith service from outside the cluster without using port forwarding. First, get an external IP address for one of the nodes. Let's see. So let's use this one. Now try hitting the secured monoliths using curl. So this is a command, and whenever it says external IP, delete that and type in any of the externals IP. I will try with, let's try this. Oh, well, let's go again. Let's do it by hand. Paste this. I will delete external IP and copy my external IP address 34.173.27.155. It says failed to connect 34.173.155. Connection refused. Okay. What timeout was going on? Now it's time for a quick knowledge check. Use the following commands to answer the question below. Let's see what happened. Kubectl services. Here it is, clustered. And describe services. So the name is monolith, the label, it has no labels. Okay, let's add a label. Adding labels to pods. You can see that you have quite a few pods running with the monolith label. That's this too. But what about app equals monolith and secure equals enable? Notice this label query does not print any result. It seems like you need to add the secure equals enable label to them. So use kubectl label command to add the missing secure equals enable label to the secured monolith pod. Basically, we're just adding a label here. Now that they are correctly labeled, let's try it again and describe this. Let's try it again. External IP. Which external IP should I use? So 34.173. Four 173, and now I forgot the rest of the number. 27.155. 27.155. And now it says hello world and running. Yep. Now we have content. Yep, this assessment is now complete. Task 9 is about deploying the application. It's just an explanation because the actual work will be done here. So we'll break it into 3 separate parts: authenticate, hello, and front end. Authenticator users, greet authenticator, and route. So let's check the deployment file. Here it is. Now let's create our deployment with kubectl create. It says it is created. Now let's create a service. Kubectl create services. It says it's created. We will do the same thing. Files created, and one more time we will expose the front end deployment with kubectl config mac. Here we go. Yeah. There's one more step to creating the front end because you need to store some configuration data with the container. So to interact with the front end by grabbing external IP and then curling into it. Let's see. The external IP, it says pending, but let's run it again. Now it is shown here. And curl. We will delete external IP and use this one. 34.70.224.155. And now we have to reply a message of hello. And this test is completed. Congratulations, this is how we completed this lab. Thank you very much, guys, for participating. In a brief, we got a few code from the cloud. We started working on Kubernetes, creating pods, interacting with those pods, creating services, adding label to that, and deploying them. Thank you very much.